Hi, everyone. Thanks for coming. We're going to talk about type safety for the next, we're going to nerd out for the next 22 minutes on specifically about TypeScript. So I'm assuming, most folks in the React community use TypeScript. I think most folks doing any sort of JavaScript these days are using TypeScript, and we like it, right? I mean, we get confidence in our code. We get really cool autocomplete in our editor. We can refactor without too much concern, and we get fewer runtime exceptions, or that's the goal, right? In summary, we as developers, as JavaScript developers, we never want to see this again, right? That's the dream anyway, right? We never see this particular exception in our console or anything, right? And any runtime exceptions, that's the dream. However, TypeScript is not really type safe. I mean, it gives some type safety, but it's not like properly type safe. It's not sound. It's not a sound type system. So it doesn't exactly deliver on the dream that we never have to see this again. And if you've done any amount of TypeScript, you kind of know what I'm talking about, right? You're still going to see some runtime exceptions. So, you might think to yourself, well, that's because developers are using these unsafe features or the escape hatches. But like I would. And I'll show you an example here that even with the strictest options, and even if you don't use any of the kind of unsafe escape hatches, it's still not a sound type system, right? And I'll show you an example here, right? So here we have an array of strings, and we don't really need that type annotation because TypeScript can trivially infer that that is an array of strings. But and then next we have an array with a broader, that can accept string or number, right? And so we're going to put the array of strings into the array that can absolutely accept strings, right? Now, some of you might, if you've been doing TypeScript for a while, might know that this is unsafe, but your hint would be this. So, of course, arrays are mutable in JavaScript. So what happens if we put a number in there? It's going to go into both arrays, right? By which I mean there's really only one array here, right? But now we have a number in our string array. And this is, you might think, okay, this is an edge case, and maybe it's not that big of a deal. And that's kind of true. But it illustrates, or I use that example to illustrate a fundamental design choice with TypeScript, which is that TypeScript chooses to be pragmatic over being sound. Right? TypeScript in general is just like, look, let's get some type safety, which is better than zero type safety, and let's make it fun to use and a good developer experience, and we're not going to worry too much about all the edge cases, right? And I think that's fine. In fact, I think it was largely, I think a lot of TypeScript's success, especially early on, was because of this principle, right? Which is that, hey, we're not going to be perfect, but we're going to be good enough, and it's going to be fun to use, right? So being pragmatic. But this talk is about type safety. So what we want to do, especially considering it's been like a decade since TypeScript has been around, it's been over a decade, and the ecosystem has changed, and we want more type safety now, right? So we're going to talk today about how can we maximize type safety with TypeScript? Like, what can we do to get better type safety? And why would we want to do that? Kind of for the same reasons that we saw earlier, right? In particular, because we just don't want runtime exceptions. Right? We don't want to find out in production that our code doesn't work. Okay, so where does TypeScript fall short? Some of you probably already know where it falls short or where the kind of gaps in TypeScript are, but it's not null safe, at least not by default. You can squeeze some null safety out of it, but there's tons of ways to disable type checking, right? Any is the obvious one. There's like type assertions. There's all kinds of things. And then, of course, like TypeScript doesn't have any knowledge about data coming from outside of your code, right? Because TypeScript disappears at runtime. And so it only knows about what's in your code at compile time. There's no built-in mechanisms for validation. And so, and there's a few unsafe defaults. And so we're going to look at some of these today. But we're also going to look at what can we do to get better type safety out of it. So there's, broadly speaking, 4 things that we can do as developers, right? Because, I mean, we can't change the language unless we want to make a pull request to TypeScript. But what can we do? We can make sure that we have stricter config, and we can mess with our tsconfig a bit. We can add some lint rules to prevent us from doing some bad things. We can do some stuff with global types that I'll show you in a moment. And then kind of the big one is, what can we do with the I/O boundaries? What can we do with data that comes from the outside world? So we're going to first kind of look at what I would consider to be a little bit of the low-hanging fruit. And that's kind of the first three, right? And I'll show you how like these are not much effort, especially on greenfield projects. They're kind of a no-brainer. So stricter config. So we're going to talk about these two rules. In fact, these are the only two rules that I care that you have in your tsconfig. Like, you got to have these. Strict, we're going to start with strict, and I would assume that most of you have that. So like the official definition is like turning on strict is equivalent to enabling all of the like strict mode family of options. And I'm sure most projects have that. It didn't used to be the default. It now is. What are the family of options? It's like all this stuff that you kind of don't need to care about, other than to know that it's not on by default in some projects. But like this is kind of legacy stuff from when TypeScript was a lot less strict. It was a lot looser. So you want to turn that on. Strict is true. And then the other one that you want to turn on is no unchecked index access, which is relatively new. I mean, it's 2 or 3 years old now, but it's sadly not on in a lot of code bases. And I'll use someone else's words to describe it, which is the no unchecked index access is the most awesome config option you've never heard of, right? Which is unfortunate, but it is really useful. And I'll show you a couple of examples why you want to turn this strictness rule on in your tsconfig. So many of you would look at this and you would know that this is going to blow up into runtime, right? This code's not going to work. But TypeScript, by default, will be like, yep, that checks out. You got an array of strings, and you can call to uppercase on a string. No issue there, right? You know, and the object variant of it is this. Like, here's an object that has like keys that are strings and values that are strings. I just want to grab some arbitrary property and call to uppercase on it. TypeScript's like, yep, that checks out. There's strings in this object for sure. Of course, this will blow up. So you got to turn on your. So you turn on that option. Both of these will be an error, right? Because it'll say params.username might be undefined, which it might. Interestingly, like anecdotally, this is like real code from a real code base that I was reviewing, and so like the top line is what the coder put, and I was like, why would you put filter and then just grab the first element when we have find? And they were like, oh, because find might return undefined, but the first one will never return undefined. I think that will return undefined. So what happens is, like, because it's not type safe, or because it's not strict enough, people lean on that, like, lean on those loopholes, I guess you'd call them, right? So anyway, turn on your, make your tsconfig stricter, and you won't run into situations like this. So, okay, lint rules. Why are we talking about lint? Because TypeScript has escape hatches, and it's good that TypeScript has escape hatches. We need them sometimes, but we want to make lint kind of yell at us if we do. So we want to make it so we have to explicitly kind of opt into using an escape hatch. So we want to, okay, we have to like ESLint disable if we want to use this escape hatch. What am I talking about? Typically any. So like you should probably have a lint rule that says just don't use any. And then the times when you really need to use it, you can just explicitly turn off that lint rule for that line. Type assertions as is probably a more controversial one, but generally speaking, you shouldn't use the word as unless you're a library author, or unless you're writing the word as const, which is great. But any other use of the word as, let's skip it. Non-null assertions, you may not know about this one. It's a little bit like unusual, and if you don't know about it, great, because you probably shouldn't use it. And then the last one is that you can write a function and type it as just function with a capital F, which is like not type safe. So anyway, these are things that like you probably don't use the bottom two, and you shouldn't, and we should disable them, and we should use lint to do that, right? So we have TypeScript ESLint. And it's great. And all you have to do is say, let's just use the recommended rule set. And if you're brave, use the strict rule set, and you'll be good. And then you'll get this, right? So you'll try to use any, and it'll say, no, you shouldn't do that. And sometimes I love the wording. It's like specify a different type. Okay, so that's kind of the first two. Like I said, easy. Just configure some things. Recommended lint config. You're good to go. Global types. So this is an interesting one. So as many of you probably know, if you do JSON.parse, it's going to give you back a type called any. And so this actually illustrates that even if you make a lint rule that says you can't use the word any, any's will creep into your code, as you probably know. And so in this case, it's just going to let us call random methods and properties and things on there because it's any. So what we really want is we want that to be typed as the better variant of any, which is unknown. And so how do we do it? Well, sadly, the built-in JSON.parse definition, like the type def for that built-in function is kind of looser than we'd like, and so we want more type safety. So you go into your global.t.ts, global.d.ts, and you fix it, and you write up, you augment the built-in type defs. It kind of sucks, but it's one line. You got to do it once, in your code base, and you're done with it. And then kind of similarly, the array example. So array.isArray, it says, okay, cool, here's an array, but an array of what? It's an array of any, so it lets you do all kinds of funky things on that, which again, you probably just want to go in here and just say, okay, well, I want this to be an array of unknown, so I can't do anything bad with that. But again, like this list is going to grow now, right? So there's a few more of these, and it kind of sucks. Like, do I have to like paste some magic global d.ts if I want type safety? And luckily, the answer is that you don't have to. So you can go out on NPM and you can pull in tsreset, which is relatively new, and it's kind of awesome, and it just does that for you. It's like, hey, here's a better set of defaults for your types. So again, like community to the rescue, we don't have to do as much of the legwork there. So what do we get then? It says, okay, well, result is of type unknown, because sure it is, right? Like we parsed it from who knows what. There's no guarantees about what is or isn't in that data type, right? Okay. So now we get to the harder stuff. So that's relatively easy. It's like pull in an npm package, configure your tsconfig. But what about like kind of the I/O boundaries, which is, I guess, to be more specific about what I mean by this, this is anything that comes in from the outside world to your code, or to put it in another way, anything that TypeScript can't infer at compile time, or can't know about at compile time, because it doesn't exist at compile time, right? So stuff that's coming from the database, anything that's coming from an API, a server, request response stuff, user input, so like CLI args is kind of an interesting one, query params. Really anything that gets parsed from JSON, you're gonna see a theme here. There's a lot of like JSON stuff coming into play. But if you use, so on the database point, if you use Prisma or some kind of like type safe database system, you probably don't have to worry about that. But if you're writing SQL, TypeScript can't really inspect your SQL query and have any clue what's gonna come out of there, right? Okay, so what do we do about this stuff? Well, here's like a, I guess, simple example right off Express's, kind of getting started or whatever. The idea is that you get this thing called request.body. It has some sort of user input, like presumably some user out on the internet sent you this data. But this would not be TypeScript will allow this. It'll be like, sure, okay, request.body has some data. We don't know what, it'll be any. And you can just grab the title, the content. But in reality, we didn't validate anything. And there's a lot of code out there like this. And it's just kind of, it's not a flaw in TypeScript. It's just TypeScript can't know about this stuff, right? Okay, I mean, that's probably basic. You all kind of know that stuff. But what is the solution? So the solution is we just want to use a validation library. And so like this is a really good one, right? This is kind of the hot one in the TypeScript community these days. How does it work? You specify a schema and you say, okay, my request body will have or needs to have these two fields. This is a string. This is like, you put optional things in there. You can nest objects. You can kind of describe anything you can in TypeScript, but you describe it using this kind of like DSL, this kind of language that will then create a validator for you, right? Validators aren't new, but Zod is a really good one. So what do you do with it? You're kind of forced to parse the request body before you can do anything useful, right? So if we didn't have, so here, we're gonna essentially validate. It's called safe parse, but we're essentially gonna validate the body before we can do anything. And then this block here, we need to have that. So if we don't have that, TypeScript will complain. So it forces us to have this. And in this case, we're just gonna send a 400 or whatever, right? So that generally falls under the category of schema-based validation. And essentially, Zod is the solution to a lot of what we saw on the kind of I/O boundary slide, right? Like most of that stuff can be solved with just writing a schema and validating some data from, the user, the network, what have you, right? Okay, so now we're going to look at like a slightly different manifestation of roughly the same problem, which is the fetch problem, right? So now we're on the client and we're saying, okay, well, I got to fetch some data. We're gonna get movies, and we'll parse it into JSON. And again, like TypeScript's gonna say, well, I don't know what data came back, so I'll let you do whatever you want without any type checking, no auto-completion, nothing. And unless you install tsreset, in which case you're gonna get a complaint here saying data is of type unknown, which is correct, it is unknown. But what is the solution here? Like what are we supposed to do in this situation? And I don't know that there is like one solution, but typically what you'll see is you'll see a type assertion. Someone will just say as. And I know I said earlier as is bad, and it kind of is, but this is a case where we may not have that much of a better option, so typically you'll see people use a type assertion here. But I am going to show you a better option. And what we should probably do here is, so here we've essentially written the type. We've said, okay, response body is of type object with a property called movies, and that's an array, and then presumably we have this movie type somewhere, but we had to write all that, unless we got lucky and our server system provided it or something. But what we probably really want to do is generate it. Like, we don't want to write all those types. So you could pull, again, community to the rescue here, pull in something from the community, generate your types. It's a little boilerplatey, so you end up having to say, okay, here's my generated schema. Now I got to, out of that like huge generated thing, I got to pull out, okay, the movies endpoint, the get request, I want the 200 response, the JSON, but so at least it's type safe, right? So if you misspell one of these things or if you put the wrong endpoint, it's going to complain at you. So it's type safe, you get your response body, and then you can do your type assertion. But there's no validation going on here. Again, this is just like telling TypeScript, hey, trust me, it's going to be of this type. Now, if you don't want to do all that, you can kind of take it one step further, and you could just use a fetch that can kind of leverage. I have a code example on the next slide. So this is, I mean, there's tons of libraries like this, but this is just one example where you can say, all right, well, I've already generated my schema here. Now I'm just going to create a client that will kind of give me a little bit of a nicer developer experience where I can say, okay, if I forget a property there in my body, it's going to yell at me. Down at the bottom, if I, call a property that doesn't exist, it's going to yell at me. So again, what you really want to do is you want to have types. You don't want to write it all out yourself, because if you do, it's going to get out of sync with what the server has. So it would be nicer to generate it. So that's the goal. Of course, if you use GraphQL, you don't really have this problem, or you're already used to code gen, right? Like most GraphQL libraries give you really good type systems. Or if you're using TRPC, you're like laughing in the back of the room because you're like, we don't need any of this stuff. Like code gen, this is so 2021, right? Like TRPC is awesome, and you don't even have to do any code gen, right? Like it does some magic so that you can just call methods, right? You can expose methods on the server, and you just call them from the front end, and everything's type safe, and it's awesome. But it does require that you kind of control the back end and the front end. It does kind of have a bit of a proprietary thing going on that maybe isn't the best for like a public-facing API. But if you can use it, great. Then you don't have to worry about everything we just talked about. So yeah, TRPC is really cool. It gives you end-to-end type safety. And if you can use this stuff, you absolutely should, right? Get the most out of TypeScript. Okay, so routing and navigation, I don't know that this necessarily falls like under IO boundary. It's sort of an IO boundary, but the idea is that in a typical routing situation, you're going to have routes with paths, and these paths are going to be strings, and they're going to have special placeholders in them that have meaning, and then you're going to render some React element, presumably whenever someone hits that route. So no issue here. This is good. But then, like, if I misspell something here, it's not even that it'll go to the wrong route. It's just like, I can easily put something in the to prop that just doesn't exist, because this component doesn't have any concept about what routes exist in my application, right? So, like a lot of mistakes happen in this space. And what's worse is you come over here to like the implementation of a component, and after you navigate to a component, it needs to know, well, what parameters were passed through. So it's going to say, okay, well, I'll just have a hook, use params. But like, what is the type there? Well, TypeScript doesn't know, right? And so what is the solution here? What typically, did the official docs tell you to do? Essentially, they tell you to do something like this, where it's like, hey, you just need to write the type at the top, which this type is not even right, but write the type at the top, and then just like throw it in some angle brackets. And again, this is just us telling TypeScript, hey, you can't infer what's going on, I'll tell you what's going on. But this is no different than a type assertion, right? I mean, this is the same as this, right? I mean, this is us essentially lying to the type system, and TypeScript will let that fly. Now, sadly, there's not much of a better option if there just isn't that many great options for like really type safe stuff in this situation. However, if you're daring and you want to use stuff that has a beta tag on it, there is type safe routing in the world, right? In fact, this is the only one I know of, and there's all kinds of magic going on to make it work because it is a hard problem. But the long and the short of it is, the community is really rallying around good type safety, and it doesn't come out of the box, right? You don't get really solid end-to-end type safety out of the box with TypeScript. So you have to do a bunch of stuff, but the community is making that easier. So I think that's really exciting. So what does the road to better type safety look like? Sure, you got to configure some stuff. Again, you kind of only do it once at the beginning of your project, but you got to configure some stuff. You got to avoid the bad parts. You want some better types for some built-ins. You got to do some schema validation. You're gonna have to write some Zod schemas or whatever library you use, IOTS, what have you. Type gen. It's a huge help. And then you just want to kind of lean on the ecosystem for things like TRPC and Zod. So that's my talk. I'm Simon. I'm a software engineer, founder. I've worked at a bunch of big tech companies. I teach TypeScript, among other things. And you can find, I don't have the slides up, but I'll put the slides up. But that's the link. You can find links to my slide decks. So appreciate it. Thanks, everyone, for listening to me talk about TypeScript. Thank you.